Today, we are going to continue with our series on what data pipelines look like in Prescient and how to do it the correct way. So, essentially, until now, we've looked at very basic systems in the community with the ETL pipelines, and just generally Node-RED allows you to have a more flexible outlook to this in a more easy fashion. So essentially, what we had earlier was we had data in the last video. We had data sources, we had its cleaning and formatting, its fusion, any operations you have on that, any checks you want to put on that, and the data destinations. Now we will look more closely at the data fusion portion of it. So essentially, for example, let's take that we have two things, maybe a sensor data store and a maintenance system. So the sensor data store essentially creates data something like this, where you have the temperature, um, some coordinate system, the charge associated with it, and we know that this is somehow related to the physical properties of the instrument. And the second thing that we have here is the maintenance system. So essentially, we are looking at something like probably attachments like maybe the it observes vibration on an actuator or something like that. And so this has another topic, that is maintenance properties. Now the cool thing about this is you can essentially have as many sources as you want, and your connection, as long as it stays in this format, is literally just a wired connection here. So some other information here is, so we have, I want a fused data store. So a fused data store essentially allows me to keep checking the values outside. This is something on the Prescient Designer. You can choose how you want to store your data. So if you want your global to be memory only or in a file context. So the file context is a lot more persistent. So let's just dive into what the fusion looks like. Until now, so a classic example is like the join, where essentially we are looking at join data outputs according to whatever settings I have. The like over here, this essentially joins the data, and it keeps replacing it with the most recent value it has gotten associated to a particular topic. And this can, it won't matter even if you have multiple topics. Right now the topics are maintenance properties and physical properties. Essentially we can have a lot more of those, um, unless they're extremely large packets and your system has a compute resource deficiency, you're going to be fine. The next version of this, it's a pretty basic fuse, very similar to the same settings from the join. So essentially, whatever new packet I have coming in as the payload from my data stores is just assigned, it's just kept in the data store with that uh, topic assigned. And so essentially over right here, like this is what your data store looks like at this point in time. This is the file option. This essentially allows you to pull from the file and store in the file. And what this, so this is also pretty similar output. Um, the cool thing about this is, well, you can access the fuse data store from outside also, which is essentially, it could be useful if you need to check anything at any point, if that is a different feed altogether that you cannot have as a part of this pipeline for some reason. Um, Then you can use the fused data store variable to fetch values. A more advanced version of this is the Fuse 2.0. So the Fuse 2.0 essentially is a little more advanced in the sense that now this makes sure that the timestamp that it is receiving is the newest timestamp for a particular object. So essentially, when my data is coming out with a particular timestamp, this makes sure that it is being fused with the latest timestamp. So in case there is a situation where we have, for some reason, older packets being brought in, this will be resilient to that. We can have a lot more options being put in here. You can put in, for example, a selection of only particular topics that you want to subscribe to. In this, you can have any other requirements that when this particular topic, when one topic is in a particular state, then only you want to fuse data from another source. Or so essentially this is a pretty flexible pipeline here. Whatever options you have, you can just put those in, and essentially with an output like this, it's pretty similar. And sorry, so with an output like that, it's pretty similar, and we can just have these payloads like this. So this is what Fusion looks like. Essentially, it allows your Fusion for one particular data source is going to look very, very similar to its to Fusion for all other data sources. You can put in conditions on singular data sources or multiple data sources according to how you want it. This kind of an architecture makes it pretty easy to do that because there's only one place in your entire pipeline where you have to list your rules, and that's that's essentially how a basic version of this pipeline works. In the next version of this video, we'll also be looking at data operations you can do. There are some pretty interesting tools out there. We have an entire series on Danfo on Node-RED, and so essentially the operations can also come in from multiple nodes in the palette. We'll look at all of that in the next video. And Fusion is also pretty flexible. You have different kinds of Fusion. You can also delay fusions and things like that using specialized nodes like this, like the delay node. So this is the data fusion video, and we'll look at the other things in the next video. Thank you.